Yes. So we were discussing this concept in the earlier class. A raised to power n plus b raised to power n is divisible by a plus b when n is any natural number. When n is odd natural number, sorry. And a raised to power n minus b raised to power n is divisible by a minus b when n is any natural number. Okay. And if n is even natural number, then it will be divisible by a minus b, of course, and also a plus b. Okay.
Yes, sir.
Clear any doubts? No. There is also additional point that a raised to power n plus b raised to power n plus c raised to power n is divisible by a plus b plus c, where n is a odd natural number. Okay, it is similar to the property that is just written above it. Okay. So moving
Yes,
on.
sir.
Yeah, today we will try to solve questions on a faster pace. So as we can see in this question, so first let's try to simplify so that we'll be able to apply properties, and that will be happening only if the base of the logarithm is same everywhere. So it may be written as we can write it as logarithm of 2 to the base n, logarithm of 3 to the base n. Basically we are reversing the log. Understood?
Yes, sir.
Yes. So this is the statement now, where n cannot become 1. Okay, great. So we know the property, the sum property. Now they will all get multiplied. Agree?
Yes, sir.
Yeah. So what is 100 factorial?
Which is 100 into 99 into 98. It goes on.
Yes. So is that equal to somewhat this? Because one is there's no much difference, right?
Yes, sir.
Can we write it as logarithm of 100 factorial to the base n, and maybe write it as logarithm of n to the base 100 factorial? Yes. So A is the correct option. Any doubts?
No doubt, sir.
Okay. Now answer is correct. So the binary number expression of the decimal number 31. So 31, it is an odd number. So we have to subtract 30 by 2, 15. Odd number 14 by 2, 7. Odd number 6 by 3, sorry, 6 by 2, 3. Odd number 2 by 2, 1. So how many ones we have? So the 31 decimal numbers binary expression will be 1 1 1 1 1, 5 times 1. 5 times 1. D should be the answer. It is correct. Any doubts?
No, sir.
Doubts. Great. So this is another question from sets. And these kind of questions have higher probability of getting asked because they have multiple questions in it. Why multiple questions are given? Because solving this question itself takes a lot of time. So that's why to compensate that much time. That's why to compensate that much time, two questions are given. Okay, so let's try to solve that. In a class, 50 students are good in Hindi only. 63 students are. Now I am going to solve questions like how should an NDA aspirant should solve. So, like reading part only, not explanation, of course, because I'm a teacher. So, in a class, 54 students are good in Hindi. Hindi is a one set. 63 students are good in mathematics only. 41 students are good in English only. Okay, so Hindi, maths, and English. And there are 18 students who are good in both Hindi and mathematics, 10 good in all three subjects. So there are three sets. Okay, so Hindi and mathematics and English. Okay, So 54 students are good in Hindi only. So in Hindi only means only the region which is not getting intersected anywhere. So 54 number. 63 students are good in mathematics only. So let me rewrite it again. Because this is for just better understanding. You don't have to do how I am doing because I'm my objective is to explain it better. Okay. So this pink shaded region is the number of students who study Hindi only. Okay. So this is 54. 63 students are good in mathematics only. So this violet region. 41 students are good in English only. This is 41. Now there are 18 students who are good in both Hindi and mathematics. So 18 students who are good both in Hindi and mathematics. So this, we use a different color. So this blue region, whatever there is inside, it is including 18 students who are good in Hindi and mathematics. And there are 10 students who are good in all three subjects. So 10 students who are good in all three subjects. This color. So this yellow color is 10 students. Okay, great. So now we have all the information and 18 are good in, yes. So now we have written all the information in the Venn diagram. Is everything clear that how have I written? So what is what? Clear?
Yes, sir.
Yeah. So first question is, what is the number of students who are good in either Hindi or mathematics, but not in English? But okay. So either Hindi or mathematics means Hindi and mathematics union set. Hindi and mathematics union set. Okay. But not in English. So we have to exclude whatever the part of English set is intersecting it. So okay, 54. So in this, either Hindi or mathematics, but not English. Okay. So we can take the pink part. Yes, 54. Do you agree that 54 students are good in Hindi and not in English? Because there is or here. So we can take students from Hindi only because there is or, there is no compulsion condition like there. If there were uh, and written here, then we have to take students from the intersection only. Okay.
Yes,
So
sir.
Hindi 54 or mathematics. So 53 minus, okay, and also like these 18 students. No, but some students in 18 set must be belonging to English, right? So how can we find out the number of students in the white region? If this complete is 18, this much is 10. So how we can find out this?
Is it 8?
Yes, it is 8. Very good. So Hindi or mathematics or both. So 8 minus students who are enrolled in English. Okay. So, but not in English. Okay. So we do not have to minus because we have already taken only those elements which are not in E. Okay. So we don't have to minus anything. So 54 plus 8, 62 plus 53. Is everything clear? Okay. Any mistake? 54 plus 8, 62. 54 plus 3 plus 8. Okay. 54 plus 3, 7, 107, 115. Wait a minute. Yes. So I think we have done some. Yeah. There's a mistake. 63 students are good in mathematics only. So there should be 63. You also take care of these small mistakes. So now this becomes 125, option number C. Is that clear?
Yes, sir.
Yeah. Now if we talk about this question, what is the number of students who are good in Hindi and mathematics? So the students must be good in Hindi and mathematics, but not English. So now tell me, it's very easy. Do you know?
Mm,
The students has to be good in Hindi and mathematics both. So like the intersection, but not in English. So in that intersection, number of students who are interested in English should be subtracted. Yes. Any guesses?
mm, is it 10?
Uh-huh. 10 is the number of students
1 minute,
who,
sir.
yeah, you just spoke that number in the class today. Good in Hindi and mathematics. So both. So the intersection set, but not in English. So these are the number of students who are interested in English. So they has to be subtracted. So 18 minus 8 becomes
It's
yes.
10. Oh,
Ah,
18 minus 8. 18 minus 8 becomes 10, sir.
yeah.
18.
Sorry. 18 minus 10 becomes 8.
Ah,
Okay. Clear?
yes, sir.
Yes. So this can also be preferred. C and D, correct answers. Yes. Let's solve this one. Question logarithm. So base is 15 everywhere. Okay, great. So x plus logarithm 15, 1 plus 3 raised to power x is equals to logarithm 5 to the base 15 plus logarithm of 12 to the base 15. So let's try doing something. Let's bring all the terms of logarithm onto the right hand side and bring this x to the power of 5. 5 raised to power x 50 plus. So if the base is same, they can get multiplied. Do you agree?
Yes, sir.
Minus of logarithm 15 into 1 plus 3 raised to power x. Okay, great. So this is x is equals to logarithm of 12 5x 12 into 5x to the base 15. And if these are getting multiplied, so they can be written in subtraction. Okay, now what we can do now is we can write x as now simplify 15 raised to power x is 12 multiplied by 5 raised to power x divided by 1 plus 3 raised to power x. Clear? How have I written so?
Yes, sir.
Yeah, we have simplified logarithm. So 12 into 5 raised to power x, this will go into the denominator. 15 by 5 raised to power x can be written like this. Do you agree? Yes. Any doubts? Any doubts? We have simply taken this 5 raised to power x in the denominator. Okay. And then if this is the case, then it may be written like this. So 3 raised to power x into 1 plus 3 raised to power x is equals to 12. So, oh, yeah, this has this, if this becomes 3 and this becomes 4, then our equation will get satisfied. So if x is equals to 1, this will be this will be happening here. Okay, clear? Any doubts, or should I explain how to find the value of x? Should I explain again, or clear? It's basic observation. By seeing only and thinking for x values, you will be able to find out by hit and trial method. Otherwise, also you can let 3 raised to power x as k and go for the longer method, which is not desirable to do so. And even with this method, you will be able to understand what are the two factors of 12, which are separated by, like, what are the old factors of 12? It can be written like this, or this, or 3 into 4. So the difference between the factors has to be 1, because here it is the case. So the difference is 11. No. Difference is 4. No. Difference is 1. Yeah. So this has to be 3. This has to be 4. This will happen only when k is equals to 3. So if k is equals to 3, 3 raised to power x is equals to 3, x is equals to 1. Any doubts? So C is the correct answer. Yes, it is correct. Solving 245 question. This is a question from sets. So whenever this kind of a question comes, you simply draw the Venn diagram. If you don't know the relevant properties are not useful, then simply draw the diagram. So there are two sets.
So we're doing these questions, we'll get practice to it.
What?
No, sir, like we are drawing diagrams and then finding it out right now. No. So if we do that again and again, will it get practiced for us?
I didn't understand. Sorry, could you repeat?
No, sir, like to find the answer, we are drawing Venn diagrams and then doing it.
Yes.
So I have also tried the same, but it is taking time for me. Like slowly I am drawing one and each and only one. So like that and all.
Draw like this. Okay.
Okay.
Okay. You don't have to represent this particular answer sheet to any UPSC board. Simply draw like this so that you will be able to understand. That's the only objective. Okay.
Okay, sir.
Tanish, are you busy these days?
No, sir.
No. At least say yes so that your late coming can be justified. Okay. Anyways, so let's focus on the question. A, B are the subsets of X, where C set is A intersection of B complement. So, come on. So, what is B complement? B complement is this. And intersection with A. Intersection with A is this much only. Yes? This much only area is intersecting with A. So, you go away, Mr. Yes, now. So, this diagram is of A intersection B complement. Union with A complement B intersection. So you may understand right now that it will be just this, right? A complement of B intersection. Intersection of A complement in B set. Now these both figures are getting unified. So we may unify both of them like this. Are you able to visualize how have I done so? Okay, so this is the C set. This basically is C set, the shaded region. Okay, then what is C equal to? Now we have to find out this C set using these options. Okay, so let's try to find out. Let's solve the first question first. This is the most used term in two options. No, it is not. It is not. The two are different. Okay, everything is different. So we have to try. And let's focus on luck so that we can take less time. So the first question is like A union B, A union of B complement. So it's B complement is this and unifying with A. So it's same, whatever is there, shaded region. It's getting subtracted by the by like this shape. Let me first make a copy of it. Okay. So where were we? We have solved this. Now, sorry, first option. We have solved this and we have to subtract B complement intersection with A. So this will be the case, right? Do you agree? Because we have just solved for it here. Okay. So now if we have to subtract this particular region from here. So what it is like to do so, that we have to just bring this moon of A. This moon of A. Yes. Array R. Nice. Good things are happening. I think some Bhoot Pret have came in our class. Okay, there's a problem with the slide. So let us solve somewhere else. Simply, let me. Okay. And also, this was our C set. The C set, basic. Okay, so let's draw rough only. So we are solving for option number A. A union of B complement. A union of P complement B, so is like this, and also the outer region is included. Okay, the outer region is included. You should draw only. We're trying for A option. So A union of B complement will look like this somewhat, and minus of A intersection with B complement. So we are basically minusing this reason only. So our option number A figure will look like this. Is that clear? Any doubts? Which is not equivalent to C set. Okay, any doubts? If any, please ask. Drawing the next figure. Okay, so this second option, the second term will look somewhat somewhat A complement intersection with B. Okay, so this is the second term. Now the first term will look like A complement unifying with B. So it is like everything else than A. Okay, and it is getting subtracted by this. So this will also look like the first option. So B option is also not the correct. Is that clear, or should I draw it properly? Is that clear? Okay, यार ये देख के पता लग रहा है. Option number C should be the correct answer. A union B is basically everything included in these two. If we subtract the intersection part, what is remaining is this, which is our set C given as. So C should be the correct answer. Is everything clear? Any doubts? Is it? Yes, C should be our correct answer. Any doubts, anyone? No doubts. Great. If we define a relation on the set of natural number to natural number, relation from natural number to natural number as AB, okay, related to CD. Now you may confuse this time because as the element of the relation set is given as ordered pair. So how many variables do we have to deal with? Is two variables in the input and two variables in the output, somewhat like this. So they will follow a relation only and only if A plus D is equals to B plus C. So let's check for reflexive straight away. So if we say AB is related to AB, means so it means that basically our set is a reflexive only when AB is related to AB. So let's put A place of B A and D on the place of B. So B is equals to B plus C. C is what? A only, because relate this with AB is related to CD. So C is A here and D is B here. So C is A. So yes, is it equal? Yes, it is equal because our natural numbers follow commutative property. So the relation given is reflexive. Now let's check for, you can write 1, 2, 3, do not get confused with the options. Now let's check for symmetricity. Okay, so AB will be has to be related to BA, then only the set is going to be symmetric. So in this case, A is A, B is B, C is B, D is A. So A plus D, D is what? A has to be equal to No, I think we are mistaking something. Yes, we are mistaking something, and that is that we are considering these as two elements of the set, whether they are just two elements of the ordered pair in the relation. Okay, like we define relation between two variables. So x, y are the ordered pair of the relation. Okay, like they are the one element which are in the form of ordered pair, and here also we are having x as a plus b as initially, right? And y as c and d. So let's solve the question all over again. Any doubts?
No, sir.
Okay, where have you gone?
No, sir. Suddenly my mom called, so that's why. I'm sorry for that.
No. So the given relation, we have to understand one fact, that the given relation is between two ordered pair, which this as acting as a x and y, and x y is an ordered pair which is the element belonging to relation. So basically a b and c d is an ordered pair which is belonging to the relation, and it will happen only if a plus d is equals to b plus c. Now is the relation given clear? Is the given relation clear? So now let's first check for the reflexivity. So for this to be reflexive, AB should be related to AB. Okay, fine. So this time A is A, okay, D is B, D is B, B is B, and C is A. Okay, so this is true for as A, B are natural numbers and they are commutative in nature when we add them. So the given relation is reflexive. Now let's check for symmetric and transitive. Now checking for symmetric should be like that if AB is related to CD, then CD must be related to AB. For AB being related to CD, A plus D has to be C plus B. Okay, so if it is so then if now we have to check whether C plus B is equals to A plus D. Oh yes, it is the case. So the given relation is symmetric. Any doubt?
No, sir.
Now let's check whether the given relation is transitive or not. So AB related to CD, CD related to EF. That is given to us because simply what we were saying that XY related to Y R and YZ related to is YZ is related. Then if X and Z are also related, then we may say the given relation is transitive. And here in the case, as we have ordered pair as the single X, so we have written AB here. Simply, and this says that AD is equals to B plus C, and this says that C plus F is equals to D plus E. Now we have to check whether AB is related to EF or not. So for this to be true, we have to prove this, that A plus F is equals to B plus C. So let's now try finding out from these two solutions the same that we have to find out. So first, let's take the value of A from here, which is B plus C minus D. We are solving for the left hand side, taking LHS. Okay. B plus C minus D, which is A, F is D plus E minus of C. So let's solve it. C minus C, D minus D. B plus E, which is the right hand side. So hence the given relation is transitive also, reflexive also. So the relation is an equivalence relation. Is that true? Understood?
Yes, sir.
Okay, great. So moving ahead. Not many questions. Not many questions. So we have to solve this question. A is a set of multiple of 2. So it is like 2, 4, 6, 8. And B is a set of multiples of 5. And C is a set of multiples of 10. Now, do you agree? Like the every element of C will be in B and A as well. Like 10 will be here and 20 will also be here. Here, 10 is also here and 20 is also here and 30 will also, 40 will also. Agree?
Yes, sir.
So, what we can say that C is a subset of A and C is also a subset of B. Clear?
Yes, sir.
Yes, so via that we can draw the Venn diagram. And there are also some elements common in A and B. So, yeah. And C is the, sorry, my mistake. A and B are like bigger sets. So C is like the, first let's find out what we have to find out. B intersection C. So B intersection C are the elements only. So B intersection C is C set only, because what are the common elements are 10, 20, and then 30, 40, 50. So the all the intersecting elements are C only. Do you agree?
Yes, sir.
Yeah. So the intersection set will also include all the multiples of 10. So this is set C only. So this is set C. Now A intersection of C. Now what is common between C and A? 10, 20, 30. What is common? What is common in A and C? 2, 4, 6, 8, 10, 12, 13,
10,
14.
30.
Yeah, 10, 20. So all the multiples of 10, right?
Yes, sir.
So its answer is also C. Clear? Any doubt?
No doubt, sir.
Yes, it is. It is correct. So if E is the universal set, A is equals to B unit C. Then the set E minus E minus E minus A. Okay, so we have to understand that this is B, this is C. Okay, and the unification of both is making set A. So this is set A. Sorry. And if E is the universal set, we have to solve E minus A again and again. First, let's understand what is E minus A. If we draw a universal set like this, E, and if there is a set, any set like A, and if we don't include A and include everything else, so what it is basically the complement of A, right? Right.
Yes, sir.
What I explain? And if we take, if we further minus E from the complement, what is left is A, because what is A complement basically? This is basically universal set and say this is set A. Let's just say that this is set A. So this is the A complement. If we subtract A complement from the universal set, okay, we subtract this. We subtract this from the universal set. What is left?
A.
Yeah, A only. A is only left. Let's wait for some time. Continuing. So what is left is A. So these are two things which we will be very much using. So E minus A becomes A. E minus A complement, sorry, E minus A becomes A complement. E minus A complement again become A. So this is simply nothing but A. So E minus A again becomes A complement. So E minus A complement again becomes A. And E minus A again becomes A complement. So what is left is A complement only. What was A? B union C, right? So B union C is complement. It is De Morgan's law to write it like this. Any doubts?
No doubt, sir.
C should be the correct option. Binary numbers. The remainder in the quotient of the binary division divided by 1, 1, 0. So 1, 2, 4. Okay. 1, 1, 2, 4, 6, 8. Okay, I have done a mistake. 1, 2, 4, 8, 16, 32, 64. 1, 2, 4. So in decimal, it will be written like 64 plus 16 plus 8 plus 4 plus 2 plus not 1, because there is 0 there. So yeah, 16, 18, 4. Okay, 16, 18, 4. Oh, how these many? No. So this is 1, this is 2, this is 4, this is 8, this is 16, this is 32. Okay. So 32 plus 8 plus 4 plus 2, 4 plus 2. Okay, so this becomes 6, this becomes 46. Okay, so 23 by 3, 3 into 4, 3 into 8 ja, 8, 24, 3 7 ja, 21, remainder is 2. So this is quotient, this is remainder. We have to find out remainder and quotient. So what is remainder? 2. 2 can be written like 1, 0 in binary. Do you agree? And 7 in binary can be written like 1, okay, 6, 4, and like this. This is in binary. 1, 2, 4. If we add 4 to 1, this is 7. If we had 2, and then 2 plus 0, this is 2. Any doubts? So this is our remainder.
No doubt, sir.
So we have to write remainder first, but it is not matching with their options. So remainder was 2. So 2, no. Okay, let's recheck whether we have done any mistake or not. 1, 0, 3 ones and 0. 2 ones and 0. Okay, so 1, 2, 4, 8, 16, 32. Okay, so 32 plus 8 plus 4 plus 2. So 32 plus 8 becomes 40, 44, 46. Correct. 4 plus 2 becomes 6. Okay, now. Yes, one mistake. When we have divided both of the numerators and numerator and denominator with some common factor, then our remainders changes, not the question, but remainder changes for sure. So the remainder has to be 4 here. Okay, let me tell you why, giving an example. 46 divided by 6. So 46 into 7 is 42, and remainder is 4 now, and question remains the same. Okay, and why it has happened? Because basically we have divided the numerator and denominator both by 2. That's why it is happening. The remainder becomes also divided by 2. Clear? So the remainder is 110 only. The remainder is sorry, the quotient is 7. So the quotient is 111 only, which is in B option also only. So we don't have to check for the remainder, like we don't have to convert it back. And it is very simple. 1 2 4. So this 0 0 1 0 0 with answer. Any doubts? Any doubts? No doubts. Let's solve this fastly. The base is 10 everywhere. So we are going to approach the question same. It is the same question. Same question. It's homework for you. Okay. Same concept. Simple, same concept, everything. Oh, okay, this was the last question. Let me solve it then for you. X equals to log 10. This goes to the power. This will be multiplied here, right? And this will be divided. 1 plus 2 raised to power x. Now simplifying this further, 10 raised to power x becomes 5 raised to power x. 6 into 5 raised to power x on 1 plus 2 raised to power x. 5 raised to power x goes to the left hand side, and this becomes 2 raised to power x. 6 divided by 1 plus 2 raised to power x. 2 raised to power x into 1 plus 2 raised to power x. From 6. 6 factor are 1 and 6, 2 and 3, 3 and 2. The difference is one here between the factors, and is 1 here also. This has to be 2, this has to be 3. So x has to be 1 for that. The value of x is 1. Any doubts? And the answer is same. Any doubts? No doubts. Okay, so let's review our progress. Now there will be some questions from my side and you have to answer them. So
Yeah.
do you have any doubts to discuss?